Hello, friends. Part 3 of your podcast in section 10.1 in the AP Stats book. We just finished Part B of problem 10.4. Part C asks you to recall the empirical rule. You remember the 68, 95, 99, 7. And it says about 95%, so in other words, the middle value here, of all values of X bar, the sample mean, lie within a distance of M of the mean of the sampling distribution. So what is M? Well, M is going to be our margin of error, and in this case, M is 2 standard deviations. So the M in this case is this number times 2, which comes out to 0.1132. So shade the region of the axis, and that's what I showed you in the last podcast with the yellow shaded area. All right, whenever X bar, and I'm in part D here, whenever X bar falls in that region, the unknown population mean mu lies in the confidence interval from X bar plus or minus the margin of error. For what percent of all possible samples does this happen? Well, we're 95% out. So 95% of all of the samples should fall within this margin of error. On part E, they're asking you to draw in 2 possible confidence intervals for this situation. What they want you to recall is this graphic that I showed you earlier in the podcast, where each one of these lines is a confidence interval, and the little orange dot in the middle is the X bar for that particular sample of size 50. So what I would do is just choose any 2 viable, realistic X bars that could have come up for a sample size 50 and put them on a graph with the lines like I showed you. So it should look something like this. So like I said, answers will vary, but this is what you're going for. This is a confidence interval with the X bar in the middle. That's the mu you're trying to actually predict. And as long as your line is somewhere underneath this mu, you got it. So this one, they did capture the true mean, and in this confidence interval, they did not. All right, the next big step is a big step, but it's going to be talking about all things you already know. So now we're going to actually be able to calculate a confidence interval for some unknown mean mu for a population, so long as 3 conditions are in order. As long as my sample was random and of a size n, as long as the population is normal, which depends on some things, and you can pause or you can read this in the book, and as long as we can establish independence. So in problems in the future, you're going to have to write a sentence or 2, and you can see the extended explanations they give right here. I'm not going to be looking for that, and you don't have to reproduce this on the AP exam, but you have to put a sentence or 2 for each condition to verify at least that you thought about it before you constructed a confidence interval or performed in a inference test later. So the calculation of a confidence interval is a pretty simple process. It's a 4-variable equation. You get a plus and minus in here, so you're going to get 2 numbers. But basically, you're going to plug and chug. But I can't emphasize enough, taking the time to understand the thinking that leads to this confidence interval, it will really make your life easier in the future, understanding the questions that are going to be asked. So here's the formula. The one thing that's looking new here is a z star. And what this is an actual z-score, but it relates to the area under the curve. Okay, so what we got to talk about is how do we find the z-star? Everything else you should be comfortable with at this point. So this example in your book takes you through. If I want an 80% confidence interval, that means the area between the low z and the high z that I'm interested in is 80, means there's 20% left over, and that means there's 10% in the upper tail. So if I go to my z table, or of course you already have on your calculator a program called z star, which will find it for you based on the confidence level you want. So all you're doing is using this backwards to find a z-score that you would use for a particular problem. So these are going to be pretty set. For 90% confidence interval, we're always going to use this z-star. For 95%, we're always going to use this z-star. And for 99, this one. So these are pretty much set in stone. And we will practice more of this in class tomorrow.